Assalamu alaikum. In this video we are going to explain the last part of the lesson, which is about grouping of capacitors. In practical circuits, several capacitors may be connected together at the same time and in the same circuit. They can be arranged in series or in parallel. The total capacitance of the equivalent single capacitor thus formed depends on the arrangement of the capacitors. First, we are going to study the series connections of capacitors. In order to know what are the common and the different properties of capacitors connected in series, we are going to perform the following experiment. In this circuit, we have three capacitors which are connected in series across a battery. Initially, the voltage of the battery is equal to 0. Then, as we can see that the number of charges on each capacitor is equal to 0 and their voltage is equal to 0, whereas they have different capacitances which are 0.3, 0.2 and 0.1. Now if we increase the voltage of the battery to 1.5, we notice that for different values of capacitances, the number of positive charges on the plates of the capacitors are equal, and they are equal to 8. If we want now to measure the voltage across each capacitor, then using the voltmeter, we will get 0.273 for the first capacitor, 0.409 for the second capacitor, and 0.818 for the third capacitor. Notice that these three capacitors have different capacitances and different voltages, but they have the same number of charges. Now, if we decrease the voltage of the battery to 0.65 and then repeat the same process, we notice that the number of charges accumulating on the plates of the capacitor are equal, which are 4 in this case. And if we want to measure the voltage across each capacitor, we notice that the voltages are different. Then we can conclude that when capacitors are connected in series, they have the same quantity of charge regardless of their capacitances and voltages. Therefore, the capacitors are connected in series, then they have the same quantity of charge Q, but different voltages U1, U2, and U3. If we want to calculate the equivalent capacitance, then according to the law of addition of voltage in series connections, U is equal to U1 plus U2 plus U3. U is the voltage of the generator, and U1, U2, U3 are the voltages across the capacitors respectively. If we now substitute instead of U, Q divided by C, then we will get this formula by cancelling a Q, because as we've said, they have the same charge. Then the equivalent capacitance will be given by this equation, which is 1 over C equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over C3. In case of only two capacitors connected in series, the equivalent capacitance is C equivalent is equal to C1 multiplied by C2 divided by C1 plus C2. You can check it alone. Application: find the equivalent capacitance of these two capacitors which are connected in series, having capacitances which are 12 microfarad and 14 microfarad. Because they are only two capacitors, we can use the formula which is C equivalent is equal to C1 times C2 divided by C1 plus C2, or we can use the general formula which is 1 over C equivalent is equal to 1 over C1 plus 1 over C2, and the final answer will be 84 divided by 13 microfarad. What about parallel connections? In order to know the properties of the capacitors connected in parallel, we are going to perform this experiment where we have three capacitors connected in parallel across a battery. Initially, if the voltage of the battery is equal to 0, then these capacitors having different capacitances will be neutral. Their voltage and the quantity of charge across each one will be equal to 0. If we increase the voltage of the battery to 1.5 volts, then we will notice that for different capacitances of these three capacitors, the number of charges or positive charges accumulating on the plates of the capacitors are different, which are 49, 36, and 16, respectively. If we want to find the voltage across each capacitor using the voltmeter, for C1 and for C2 and for C3, we notice that they all have the same voltage, which is equal to 1.5. By decreasing the voltage of the battery to 0.65 volts, we notice that the number of positive charges accumulating on the plates are different, which are 20, 16, and 6, whereas the voltage of these three capacitors, which are connected in parallel, is equal and it is equal to 0.65 volts. Then we can conclude that when capacitors are connected in parallel, then they have the same voltage regardless of their capacitances and the quantity of charges. Therefore, the capacitors are connected in parallel, then they have the same voltage UAB but different quantity of charges Q1, Q2 and Q3. In order to calculate the equivalent capacitance, we have to start by Q is equal to Q1 plus Q2 plus Q3, where Q is the total quantity of charge in the whole circuit. Q1, Q2 and Q3 are the quantity of charges for C1, C2 and C3 respectively. If we substitute instead of Q, C times U for all the Q's and then cancel Q because they are parallel, then they have the same voltage, we will get that the equivalent capacitance of these three capacitors is equal to C equivalent is equal to C1 plus C2 plus C3. Application: I have to find the equivalent capacitance of these two capacitors which are connected in parallel. I will use the equation which is C equivalent is equal to C1 plus C2 which is equal to 7 microfarad. I have two special cases. The first one is if the capacitors having the same capacitance are connected in parallel, then we can say that these capacitors have the same voltage and the same quantity of charge. What if these capacitors have the same capacitance but connected in series? These capacitors will have the same voltage and the same quantity of charge. Then we can conclude that if there are n capacitors of equal capacitances are connected in series or parallel, then they will have the same voltage and the same quantity of charge. Application: in this application, I have a circuit which consists of 4 capacitors. In the first part, I have to calculate the equivalent capacitance of the circuit. Notice that C1 and C2 are connected in series, then their equivalent capacitance is equal to 20 microfarad. Both C1 and C2 are connected in parallel with C3 and C4, then their equivalent capacitance is equal to 45 microfarad. In part 2, knowing that UAB is equal to 36 volts, calculate the voltage of each capacitor. Because these two capacitors are connected in parallel, then they will have the same voltage which is equal to 36. The voltage of C1 and C2 both together is equal to 36 volts. But how can I find the voltage across each capacitor? First, I have to find the quantity of charge which is common for both capacitors and it is equal to 720 microcoulombs. Then calculate the voltage with using U is equal to Q divided by C. It will give 24 volts for the first capacitor and 12 volts for the second capacitor. In part 3, knowing that the charge of the capacitor C4 is 50 microcoulombs, calculate the charge of each capacitor and the voltage UAB. I know that U4 is equal to Q4 divided by C4 which is equal to 5 volts, and because they are connected in parallel, then they will have the same voltage which is equal to 5 volts. To calculate the quantity of charge of Q1 and 2, which is equal to Q1 equal to Q2 because they are in series, then I have to use C times U which is equal to 100 microcoulombs. To find the charge of C3, I have to apply the same formula. It will give 75 microcoulombs, and for the capacitor C4, it will give 50 microcoulombs. I hope that you've understood the whole lesson. Good luck and please study well.